Hello everyone, welcome in a new video. In this video, we are going to solve one more question of scheduling algorithm. This question is appear in a gate examination as well, so it's kind of an important type of a question. So the question is look like we have a processes, arrival time and a burst time. What we have to do is we have to find the value of z. What we are going to do? Have to find the value of z, but what are the things given? The given is the average waiting time, which is 1 millisecond. Average time is 1 millisecond, and we have to solve this question with SRTF scheduling algorithm. Preemptive SRTF scheduling algorithm. SRTF means shortest remaining time first scheduling algorithm, means whoever have a smallest burst time will get the CPU first. And what we have to do is we have to find the value of z. Okay, easy question. Pause the video, try to solve it by yourself, and if you are not able to do that, then see the see this video. Okay, so now let's solve this question. So solving these kind of a question, so first of all what we need is to understand that what are the things given. So what are the main thing we are looking for, because in every question the process arrival time burst time is given. What is the key point? Key point is the average waiting time. Why this thing is given in a question? Okay, so we have to analyze this thing. So it says that average waiting time for this processes is 1 millisecond. What does this line want to say? This line want to say that average waiting time is equal to 1 millisecond. What is the average waiting time? Average waiting time is nothing, just the sum of all waiting time, all the processes waiting time. What is average waiting time? Sum of all process waiting time divided by the number of processes. This is what our average waiting time is. We are finding so many times we are finding an average waiting time, which is basically the turnaround time minus the burst time. So whatever it is given, like this is what a waiting time. So what is it? TAT minus the burst time, whatever the answer is, you write that thing here. And if you sum up all these things and divide it by the number of process, in this case, the number of process is 4. So if you divide sum of these 4 processes by 4, you will get average waiting time. Okay, so this is what an average waiting time. Sum of all the process waiting time divided by the number of process. In this particular question, the average waiting time is 1. Sum of all process is the thing which we don't know. So this is what we have to find. Sum of waiting time. Sum of waiting time, sum of all waiting time. Okay, so like it. By the number of processes. So we know about this thing as well, that in this question we have 4 processes available: P1, P2, P3 and P4. So we can easily find out the sum of waiting time. So the sum of waiting time is what? 4 milliseconds. Okay, so this thing we are able to find out that what is the sum of these 4 values. This. So sum of these 4 values is like 4. So we understand this thing. Okay, so we understand the one part of the question. Okay, easily. Now our next step is to solve this question. So how we solve this question, where we have a arrival time, burst time and a process, we have to make a Gantt chart. Easy. Okay, so we have to make a, first of all we have to make a Gantt chart. Okay, so a Gantt chart. Now, so we have a 4 processes: P1, P2, P3, P4. We have to solve this process by SRTF scheduling algorithm. So solve this Gantt chart is started from a 0. So at 0, which processes are available? Only one process, P1. So if only one process available in a queue, so we execute this CPU, get that process. So P1 is execute only 1 unit of a time. Why I say 1 unit of a time? Because at one arrival time we have one more process available, which is P2. Now at one arrival time, we have a 2 processes, P1 and P2. So the burst time left for a P1 is what? 2. 2 is the burst time which is left, because 1 unit of a time CPU utilize it. Okay, CPU execute 1 unit of time. Okay, so the burst time left for the P1 is what? 2, and P2 process is also available. So at 2 process available, P1 and P2. So who we have to solve this by SRTF, means who have a smallest burst time will get the CPU. Among these 2 processes, which processes basically have a smallest burst time. So of course P2 have a smallest burst time. P2 come and get the CPU and execute completely because it's 1 unit of a time and there is no break. So it complete at 2. Okay. Now, there is any process at 2? So the answer is no. There is no process available at 2. Okay, so we have to understand one more thing as well, like P1, P2, P3 and P4. Like solve it here to understand it completely. Like so the arrival time like 0, 1, 3 and 4, and burst time is like 3, 1, 3 and Z. So the burst time left is what, 2, and P2 is completed. Okay, P2 is completed. Okay. Now we have to understand one more thing, why this thing is given. Okay, why the waiting time is given. So there is any use of this waiting time. Okay, so we write the waiting time of these process as well. So P1 come at 0, so P1 wait for someone. Does P1 wait for someone? So the answer is no. P1 doesn't wait for anyone. P1 come and get the CPU and execute and then terminate. After at one arrival time, there is an another process which is P2, So P2 get a CPU because P2 have a smallest burst time, so P2 will have a CPU. So does P2 wait? Answer is no. Does P2 wait? Answer is no. Why? Because it come at 1 and get a CPU at 1. So it doesn't wait 0. But does P1 wait? So the answer is yes, because we have a two process available. We have to choose one. We select P2. So P1 has wait for 1 unit of time. P1 is basically wait for 1 unit of time. Easy to understand. Okay. Now let's again get a CPU to P1, because now at 2 there is no process available because 1, 0, 1, 3 and 4, this is what our arrival time. So no new process available at 2 arrival time. Okay, so P1 there, so P1 will get a CPU. Now P1 is not wait. P1 wait only 1 unit of time because P2 execute 1 unit. Okay, now P2 get a CPU. P2 get a CPU. Sorry, P1 get a CPU. Okay, P1 get a CPU only the 1 unit of a time. 2 to 3. Why? And the bus time left is what, 1. Why I execute only 1? Because at 3 we have one more process available, which is P3. Now we have two processes available, P1 and P3. Okay. Now we have to solve this by SRTF scheduling algorithm. So who have a smallest bus time will get the CPU. So 1 and 3, so definitely 1 is smaller. So P1 execute again. Does P1 wait for someone? No, because P1 is continuing where it paused. Okay, so from 3 to 4, because at 4 P1 is now completed. So P1 wait for 1 unit of a time? The answer is no. So who wait for 1 unit of a time? Two process there. CPU execute 1 unit. So who wait? So the answer is P3 wait. So the answer is P3 wait for 1 unit of time because it come at 3, but we execute till 4. So from 3 to 4, 1 unit of a time, P3 wait. Okay. So two processes now completed, P1 and P2, and we have two process available, which is P3 and P4, because now at 4, P4 is also available. So two processes available, P3 and P4. Now the thing start from here. Now what happen if I select P3, because we doesn't know what's the value of Z. This is what a Z. We doesn't know that what is a value of Z. Is it greater than 3 or is it smaller than 3? Because now we have two process and we have to solve it by SRTF. Who have a smallest burst time will get the CPU. So what happen if I suppose that P3 is greater than P4? P3 is smaller than P4. Means if I see this situation, means the value of Z should be greater than 3. If a value of Z is greater than 3, then only we can say that, okay, this should be, then we can only say that now P3 is can get a CPU. If a Z value is smaller than 3, it means P4 have to get a CPU. But we suppose that P3 get a CPU, so it means what? That should be greater than, or we can say equal to 3. If it is equal to 3, then also P3 get a CPU because of our arrival time. Okay, so this is what a situation is. So if this thing happen and two process there is no new process as well. So any process get execute completely execute. So if it completely execute, bus time is what 3. So 4 to 3 means 7. 4 to 3 means 7. So how much time will P4 have to wait? P4 have to wait for 3 unit of time because the bus time is what 3. So P4 have to wait for 3 unit of a time. After that, P4 get a CPU and then it executes. But what is the key here? The average waiting time is what 4 milliseconds. But if you collect all these things, so 1 plus 1 is 2, 2 plus 3 is what 5. It is greater than what we calculate. So basically 5 is greater than 4. So it means that our assumption is wrong. Our assumption is wrong. Why I said this? Because the average waiting time should be equal to 4, but it is greater than 4. We sum of these things, it is greater than 4. If you sum all these things, you will get 5. So it's definitely greater than 4, but our waiting time should be equal to 4. So it means what? It means the value of z cannot be greater than or equal to 3. So our assumption is wrong. Okay. So, oh, okay. So our assumption is wrong. So what happened now? If our assumption is wrong, then what we have to do is we have to now put P4 and then P1. Okay. Now, now the new assumption is like the value of Z is less than 3. Value of Z, this is what our new assumption is that oh, that value of Z is less than 3. Okay. Value of Z is less than 3. So remove these things, remove these things. Okay. So our new assumption is that the value of Z is less than 3, not even equal to. If it's equal to, then we get 5. Okay. If it's greater than, then we get some of these things is greater than. We get a 5. Okay. So it should be less than 3. If it is equal to 3, then also P3 will get a CPU because of our arrival time. Okay. Now, what should be the value of Z? Now we have to make a trial and run. We need the sum of waiting time should be equal to 4. Now we select P4. Okay, guys. Okay, everyone. We select P4. So the waiting time for P4 is 0. Now the waiting time of P3 will need it. Okay. Now, what should be the value of waiting time? Sum of waiting time. The sum of waiting time should be equal to the sum of waiting time should be equal to 4. So what time we add so that we can get the waiting time 4? If we add 2, if we add 2, so we get 3. 3 plus 1 is what? 4. And we need 4. So this thing, are you understanding the plot that how we are basically finding the value of that, how we are finding the burst time of a P4 process? P3 can only wait for a 2 unit of a time, then the total waiting time for P3 is what 3, and if you sum up all these waiting time, we will get 4. And we need, so the value of that should be equal to 2. It only execute 2 units, so 4 and 2 is become 6, and after that P3 from 6 to 3 means 9. This is what again chart is look like, and value of that should be equal to 2. If a value is less than 2, means if a value is less than 2, it means for the P3 wait for a 1 unit of a time, and if you sum all these things, you will get 3. So definitely it is not equal to 4. So we are waiting for 2 unit of a time. We are waiting for 2. P3 is basically waiting for a 2 unit of a time to make this condition 4, and we need 4. So it means the assumption of our Z is equal to 2 is correct. The value of Z is equal to 2. So I hope you understand that how we solve this question. This is come in a gate exam, in a previous gate exam. So I hope you understand that how we are solve this question. Okay. Easy to understand, easy to understand. Okay, important type of a question. Sometimes the it exam can ask you question like these. You have to find out the first time, you have to find out this arrival time, or you have to find out these things. Okay, the tricky one, not regular or not regular basis. The gate exam doesn't ask you like average waiting time, average turnaround time. It asks you in this way that find the burst time. Okay, so this is what a question. Thank you for watching this video. like the video and subscribe my channel and watch the next video of multi-threading.